Hi there, today we're going to be solving equations with rational coefficients. For example 1, we have solved 7 halves n plus 3 halves equals 3 halves n plus 2. Notice all of the denominators in our fractions are 2. So what we're going to do to get rid of those is we're going to multiply by that denominator. So I'm going to take all of this and we're going to multiply it by 2 because, and I'm going to just write this over here, I'm going to show you what happens. So if I have 2 over 1, which is what I'm multiplying by, times this 7 over 2, this is what happens. We have 2 times 7 on the top, which is 14, and 1 times 2 on the bottom, which is 2. And 14 divided by 2 equals 7. Notice if we were to just cancel these 2's out, or say 2 divided by 2 is 1, 2 divided by 2 is 1, I get only the 7 along with all of these 1's, right? So the 7 is what I get if I multiply by that denominator. So over here in our equation, I can say that this 2 cancels with this 2 up here, and I get 7n. Same with this 3 over 2. If I multiply 2 over 1 times 3 over 2, those 2's cancel, and I get 3. So this is plus 3 equals, again, this is the same idea, 3 over 2n. This is going to give me a 3n. And don't forget, even though this 2 right here at the end is a constant term, I still need to multiply this 2 times that constant term to make it equivalent or equal. So I'm multiplying this 2 times all of these terms in here. So now I have an equivalent equation or equal equation. So now I can solve like normal. I'm going to solve by subtracting my 3n because both sides, I notice, are simplified. So I can go ahead and start moving my variables. I get 4n plus 3 on the left side, and these cancel. I get 4. Subtract 3. These cancel, it becomes 0. I get 4n on this side. Over here, 4 minus 3 is 1. I'm going to divide by 4. I get n equals, and notice I have 1 over 4. 1 over 4 is 1/4. So I'm just going to keep that as a fraction just like it is. All right, so our next example, let me make this a little smaller so I can scroll. Our next example is the same type of thing. We are going to multiply to get rid of that denominator. Make it easier on yourself to get rid of those denominators. We could solve with the fractions, but it's so much easier if you just get rid of that fraction. All right, so here we go. I'm going to change colors here. And I'm going to multiply this time by 7. Because 1/7 times 7 equals 1. So this is 1k. Where's the k? I'm going to multiply times the 6 as well. So 7 times 6 is 42. Actually, 7 times negative 6 is negative 42. I'm going to also multiply times this 3 7ths. So 7 over 1 times 3 over 7 equals 3. So I have 3k. and 7 times 4. And notice the left side and the right side are both simplified, so I can start moving my variable terms. K minus k is 0. Whatever I do to one side, I do to the other. I get 2k. I'm going to bring down this negative 42 and this positive 28. I'm going to subtract 28 because I have a two-step equation, so I want to get variables on one side and constants on the other. Negative 70 equals 2k. I'm going to divide by 2. And k is going to equal negative 70 divided by 2 is negative 35. Alright, so example 3 is a little different in that the denominators are not the same this time, which is okay, but it's going to make it a little different because we need to multiply now instead of times that common denominator. We're going to multiply by the least common denominator, as if we were getting a common denominator for adding fractions or subtracting fractions. So if we were adding or subtracting fractions, we would have to find a common denominator. And that's what you want to do to get rid of these denominators. So our common denominator here, let me change colors again. Our common denominator here would be 6. So I'm going to multiply by 6. So 6 times 5 6. And again, I'm going to write this on the side just so you can see what's happening, but you do not have to do that. The 6's cancel. That leaves 5. So this is 5y. 6 times 1 is 6. 6 times negative 1 half. 6 times negative 1 half. So I have 6 times 1 is 6. 1 times 2 is 2. And it's negative. Positive times a negative is a negative. 6 divided by 2 is negative 3. I have negative 3y. And 6 times 5 is 30. My left side and my right side are simplified, so I can start moving my variables. I get 8y plus 6. And over here is 30. I'm going to subtract 6. I get 8y equals 24. I'm going to divide by 8. And I get y equals 3. Alright, again, when you don't have denominators that are alike, you want to find a common denominator and multiply by that common denominator. We also have rational coefficients that could be decimals. What you want to do to clear the decimals or get rid of those decimals is you want to multiply by the largest place value. So for example, this is in the tenths place, this 2. This 5 is in the hundredths place, and this 5 is in the tenths place. So if we were to multiply all of these numbers by 100, we could get rid of those decimals. Because 0.2 times 100 is the same thing as moving that decimal 2 spaces to the right. 1, 2. So that gives me 20. 0.75 times 100 is the same thing as multiplying that decimal 2 spaces to the right. I get 75. And 0.5, 2 spaces to the right, I get 50. So now I don't have pesky decimals to worry about. I can solve with these whole numbers. So I'm going to move this 20x over here because I already have a variable term over here and no constant term. So I'm going to move that variable term over here so I can keep my variables on the right side and keep this constant over here by itself. And then divide by 30. And 75 divided by 30. We can simplify and keep it as a fraction, but because it's already, because it was given to us as a decimal type equation, we can divide 75 by 30 and write our answer as a decimal. All right, so if you have questions, be sure to ask. I can always Zoom with you. And I would like for you to try the backside 1 through 6 on your own. Try the backside 1 through 6 on your own and be ready to ask questions.